Okay, guys, so for our last look here in session 6 at loops, we're going to actually look at a program that uses loops within loops. And this can sometimes be a bit tricky to conceptualize and just visualize in your head, get your mind around it. But we'll actually take it step by step. And I'm going to show you ways in which we can figure out what's happening within the loop. Okay? So this is going to be a program that asks the user to enter a number and then determines the factors of that given number. So starting from the top, we have IO stream, which is going to be our preprocessor for input and output. Then we have our namespace declaration and then our main function. So nothing fancy, nothing new happening so far. So hopefully that part is okay. Here we're just creating a integer variable to store that number that we get from the user. So we ask the user here with the message using the cout object, we're printing out to the screen, enter any number. And then using the cin object, we save that value in the number variable. And we can get started with a first loop, loop number 1. We know it's a loop because we are using the for keyword, so it's going to be a for loop. And then we have the parameters here defining that loop. So we're going to track the iteration with the I variable, which is defined here starting at 1. And the loop will finish if I is over 100, right? So as long as it's less than 100 or equal to 100, this will equal true. Therefore, the loop will continue. And after each loop, we will get an incrementation of 1. The body of the loop is contained within the brackets, so you can see that here. Okay. And we can actually print out the value of I to help us visualize what's going on behind the scenes. To help us visualize each loop. Okay. So let's see here with loop number 2. Okay. With loop number 2, this is happening within loop number 1. And this I value is getting passed on. So we've defined this loop as having the j variable starting at 2 to track it, okay? And it will continue looping as long as j is lower or equal to I, so the factor that we're looking at. And then after each loop, j will be incremented. So you can think of it as this way. You have a number being entered by the user, right? And then basically we're checking 100 potential factors, right? That could be appropriate for that number. So we cycle through those 100 factors and we're testing them out to see if we can find any factors within those, right? So at this point, on that second loop, we're looping through 2, through a minimum of 2, to the number of the factor that we're checking, okay? We're printing out the j value so we can keep track of that second loop and what we're doing in there, so which iteration we're on. And then we check if that number is evenly divisible by, if the number is divisible by j, right? So we're testing out that factor. And if it is divisible, we basically print it out to the screen. So we identify that number as a factor. And then whatever result we get from dividing the number by that factor, we make that our new number, right? Because we want to find out the factors of that factor until we can get to the point where, we can get to a point where the number is so small that we have no further factors that we can find for it, right? And that can happen if we get to 1, right? So once we get to 1, we know that 1 is always a factor. So then we go ahead and conclude the search. Now, as you will remember, loop number 1 was going up to number 100. So it was testing from 1 to 100 as potential factors of the number entered by the user, right? So what's the point on continuing to search if we've gotten to 1, right? The factors cannot get any smaller than that. So there's no point in continuing to search for a factor of 1. At that point, we can use the break statement or the break clause to finish that loop, okay? So if once that happens, we finish this loop, okay? And we end up back on the first loop. And here we can also check if number equals 1. And then again, we break out of that second loop. Right? So it's one way to finish the search earlier rather than wasting all that computational power. So let's give it a try. Hopefully yours is loading a bit quicker than mine. Let's see here. There we go. Now that's working. So let's try 18. Okay. So let's see, let's break it down line by line, what is happening. So we've got here the number 18. We're starting with our first loop. So the value is 1, right? Comes to the second loop, and the second loop completely ignores it because, as you will remember, we're starting at 2, and we're only looking at it if it's smaller than the factor, or I, which is 1. So that would get completely skipped over. Let's see here. Then we cycle back, and now I is 2. Okay, so then we actually get into the second loop because you can see the j there being equal to 2. So we're checking if 18 is divisible by 2, which it is. So 2 is now considered a factor. And remember, we take that result, 18 divided by 2 is 9, and we store that as our new number for which we are looking for factors. So now it cycles back because we got to 2, right? So now the first loop is equal to 3. And we're looking at the second loop now with j starting at 2. So checking if 9 is divisible by 2, it is. So now we're going to store the 3, the resulting 3, as the number for which we are looking for factors, right? So again, we're here it changed to 9 because we took the result of 18 divided by 2, which was 9, right? We wanted to see if 9 had any further factors. We got it down to 3, and now we're looking for factors of 3, right? So 9 is divisible by 3, and that's why it's listed as a factor here. And we continue checking if 3 is divisible by 2. No. Checking if 3 is divisible by 3. So 3 is a factor of itself. And then we finish the search, right? 1 is a factor. Factor search is over. 1 is a factor. And that's it. Actually, what we could do here is we can get rid of the first message because we only need to really print it out once. And there we go. So that's it for our last look at loops within section 6.